Welcome to this explainer. Today we're going to completely shift how you look at galaxies. We'll be using ARP 153, also known as Centaurus A, as our ultimate cosmic case study. If you've ever looked up at the night sky and thought you totally understood the basic rules holding it all together, well, prepare to have your mind expanded.
Okay, let's dive right in by challenging a pretty massive fundamental assumption. We are taught from a very young age that gravity is the undisputed boss of the universe, right? It pulls planets, it builds stars, it clusters galaxies. But what if gravity isn't the only major player shaping the large-scale structures of the cosmos? What if there are massive, invisible forces at play that we are only just now beginning to truly map out?
Section 1. Meet ARP 153, Centaurus A.
To really understand this paradigm shift, we need to meet the behemoth next door. ARP 153, more commonly known as Centaurus A, is a truly fascinating galaxy located right in our cosmic backyard in the Centaurus constellation. At just 11 million light-years away, Centaurus A is a prominent member of what's brilliantly called the Council of Giants, which is a ring of massive galaxies in our local supercluster, and it's also a key player in the M83 group. But most importantly for us today, it's our closest active galaxy neighbor. That proximity gives us a front-row seat to some of the absolute most energetic processes in astronomy.
Astronomers actually classify Centaurus A as a lenticular DRAGN. And aside from being a phenomenal acronym that sounds like a mythical beast, DRAGN stands for Double Radio Source Associated with Galactic Nucleus. Basically, it's a galaxy featuring a massive central black hole that is just shooting out colossal radio-emitting jets. It's an active galactic nucleus behaving like a massive cosmic engine. But to understand how this engine actually works, we have to look much closer at the galaxy's core.
Section 2. The warped magnetic disk.
By peeling back the visible layers, we can actually see the unseen forces shaping the galaxy's gas and dust. Centaurus A is famous for its chaotic dust lane, which is actually a massive, warped molecular disk. And what's incredibly cool here is how we can literally map the invisible. Using thermal polarized emission, observational data of the polarization vectors in the innermost region of Centaurus A shows us exactly how magnetic fields in the plane of the sky are tightly following this 3 kiloparsec warped molecular disk. It's not just random static, it's a highly ordered magnetic structure stretching across thousands of light years.
So where did this massive magnetic field even come from? Well, these observations provide incredible evidence for galactic evolution. Centaurus A is the remnant of a colossal galaxy merger that happened roughly 16 to 320 million years ago. That violent collision didn't just smash stars together, it created intense, turbulent gas motions. This turbulence acted like a giant dynamo, amplifying the galaxy's magnetic fields until they became dynamically crucial to the galaxy's entire structure. In fact, that thermal polarized emission we measure reveals dust grains physically aligning with these magnetic fields.
Section 3. Clues in the jets.
Now, the disk is really just the engine block. Moving out to the macro scale, the most dramatic features of Centaurus A are its jets, essentially the cosmic exhaust. These are magnificent, S-shaped structures blasting out from the active galactic nucleus straight into deep space. They extend far, far beyond the visible galaxy itself, pushing out into the intergalactic medium. And yet, despite traveling through the massive vacuum of space, they maintain incredible stability over vast cosmic distances. So that brings us to the crucial mystery. How did these colossal jets maintain their tight structure and immense power without just falling apart and dispersing into the void? What unseen force is keeping them so tightly bundled over tens of thousands of light years?
To solve this, astronomers hunt for clues using a phenomenon called Faraday rotation. Without getting too bogged down in the heavy math, think of Faraday rotation as a glowing footprint left behind by electric currents flowing through space. When light passes through a magnetic field, its plane of polarization rotates. By measuring that specific rotation, we can map out the invisible magnetic fields and the electric currents that are actively creating them.
And you guys, this is where the data gets genuinely mind-bending. By comparing Faraday rotation observations across different distances from the black hole, researchers discovered a totally unexpected symmetry break. Close to the core, on the parsec scales, they observed a clockwise rotation, which indicates a net axial electric current flowing inward, right toward the black hole. But further out, on the kiloparsec scales, they saw a counterclockwise rotation. That reveals a massive electric current flowing outward in the outer sheath of the jet.
Section 4. Enter the cosmic battery.
Think about what that dual current setup actually means for a second. We have opposing currents flowing in structured layers across massive cosmic distances. It points us straight to a theoretical mechanism known as the Poynting-Robertson cosmic battery. Let's walk through this four-step process, which perfectly explains how the rotation of the accretion disk acts as a gigantic generator. First, the accretion disk rapidly rotates around the central black hole. Second, the immense radiation pushes against the plasma electrons, causing radiation drag, which generates a circular azimuthal electric current in the inner disk. Third, this drags and tightly winds up loops of magnetic fields. And finally, as these loops wind up and detach, they launch massive axial electric currents both inward along the core and outward along the outer sheath of the jet.
Visualizing this in 3D, the helical field structure generated by the cosmic battery is just a masterpiece of physics. You have inner magnetic field lines threading right down toward the black hole, while the outer field lines thread the rotating disk. Because they're constantly being spun by the disk itself, they create these beautifully nested helical spirals. It's a grand design, literally a self-sustaining electromagnetic engine. Section 5. The Galactic Coaxial Cable.
When you take a step back and combine these nested magnetic fields with the massive bidirectional electric currents we just tracked using Faraday rotation, the whole jet functions exactly like a gigantic coaxial cable. Just like the literal cable that brings internet or television to your house, though, hopefully with much better connection speeds. There is a central wire carrying current in one direction, surrounded by an outer sheath carrying the return current. Except here, the cable is tens of thousands of light years long, and the current is on the order of billions of amperes.
And this brings us completely full circle to our earlier clues. Mapping it all out, the inner wire of our galactic cable creates the clockwise Faraday rotation we observed close to the core. Meanwhile, the outer wire sheath creates the counterclockwise rotation we saw much further out in the jet. The observations perfectly match the physics of a giant electric circuit.
All of this leads us to a single, profound conclusion, drawn directly from the research. Astrophysical jets are fundamentally electromagnetic structures. It completely forces us to realize that ARP-153, Centaurus A, is not just a passive collection of stars and gas, simply being pulled by gravity. No, it is a highly ordered, dynamically active cosmic-scale electrical circuit. Electricity and magnetism are absolutely not just secondary effects here. They are the primary architects of the galaxy's most massive features. So I want to leave you with this thought to chew on. If an 11 million light-year away galaxy like Centaurus A operates like a massive household cable, generating vast magnetic fields from ancient mergers and blasting electric currents deep into space, it leaves us wondering, what other electromagnetic secrets is the universe hiding in plain sight? Thank you for exploring the invisible architecture of the cosmos with me today in this explainer. Keep your eyes on the stars, and remember, there's always more going on than meets the eye.